Oh, computer space, how you annoy me. I got to poking around on this board again today, and I found a 00 that was clearly bad. Pin 8. Okay, on the inputs we had one high and one low. So our output should have been high all the time, but it was low all the time. So that was definitely no good. So, and I did verify. I pulled the chip and I tested it on my tester and it was bad. While I was at it, I went ahead and just removed some chips. I removed the 74s. I removed this 30. And I removed this line of counters. There's 3 LS90s, 7490s, and there's a 7493 right here. The 7493 tested okay. The 90s were all bad. So I replaced the 90s. I replaced this 00. All these other chips were okay. The 30 was okay and the 74s were okay. And I found a broke trace right here. There was a trace broke right here. You can see where I jumped a wire over it, and I've already cleaned it up nicely. But that trace was completely broken in half. So yeah, my goal is to get this thing, this should sync to the monitor with just this board in, I would imagine. So, I mean, I just found a bunch of bad stuff. So let's go ahead and throw it back in the board and see if we can sync up to the monitor now, at least. Well, this is interesting. This green capacitor right there is the capacitor that goes... What's the value on that thing? It's 0.01. And the 0.01 is right here. It is the capacitor between the emitter of this transistor and looks like ground. This little tool right here is awesome. I got this. I'm actually a patron of Mr. Carlson's lab, and this is one of the circuits that he has on his site. It's a leakage tester. You can test leakage in small capacitors. Anything under a microfarad, or you can even do a 1 microfarad cap, but it takes forever for them to charge. They're really good for these, 0.01, 0.1 microfarad, 200 picofarad, 1000 picofarad. That, those small value caps this thing is great for. And you can find leaky caps. And this, you see this LED is lit. That means that this cap is leaking across it. It's basically shorted. It might not show up as a short, but it leaks electrically. It leaks current across it. That could be the reason why we don't have sync. It's very possible. I'll show you. Let me get the tripod out and I'll test these other caps right here. I pulled all of the capacitors out of this circuit right here. The basically the clock circuit, the crystal circuit. I took the crystal out too, but the crystal I don't believe is an issue. I took this. This is a LM733. It's a amplifier. It's a video amplifier, linear chip. I just removed it. I actually bought some of these, but I doubt that that's bad. I really think that this cap is the problem. It's definitely a problem anyway, because that is absolutely leaky. I'll set the camera up on the tripod and go through a couple more of these. Okay, so we know that this cap is no good. That thing leaks current across it. This is a 102. That is a point. I can't see it. It's a 100 picofarad. 100 picofarad, and there's two of them. This is a 200 picofarad. This is a 0.001. 0.001 would be 1,000 picofarads, right? I saw the 200. Now it says we have two. Let's go ahead and do some capacitor checking. This is 200. This is 200. That's 200 picofarads. Yeah. It's 235 picofarads. That's the 200 picofarad. This guy right here says 0.001 on it. Which is 1,000. It says 1,000 nanofarad, which is, or it says 1.004 nanofarads, which is actually 1,000 picofarads. So that is a 1,000 picofarad cap. And this one, this is a 100 picofarad. That one is 100 picofarad. Alright, so anyway, checking these with this tester. You see the light is off. Now if I just take my fingers and put across the leads, see that? And when I take my hands away, there's no leakage across this cap, as the LED is extinguished. But I introduce, leakage across my body, and it lights it up, and now it goes away. There's no leakage across this cap. This is actually a good cap. And we can test this one. Okay. Same thing. No leakage. I can introduce leakage with my finger. But there's no leakage across that cap. The LED goes out, there's no leakage. And this one. There we go. Same thing. I can introduce leakage, but the LED goes out. That means there is no leakage across that cap. But this green one, come on. The green one stays lit. That is absolutely a leaky bad cap. And let's test it on the meter. It is a the 0.01 microfarad. So I'll go to 2 microfarad. It'll say 0.01. It'll probably test good. See that? It tests good, 0.01. So even though this cap tests good, this cap is no good. That's why with analog circuitry and dealing with these capacitors and stuff, this is one of the best tools that I have. This thing does not look like a bad cap on the meter, but you see clearly this capacitor leaks current across it. So it's no good. So excellent. So I'm going to put these back in the board. I'll put a new 0.01 in. This one's no good. And yeah, Mr. Carlson's Lab. I'm actually a patron of his on Patreon, and that's where I got this schematic for. Please don't ask me for this schematic and stuff. It's at Mr. Carlson's Lab if you are interested. Pretty cool though. It's awesome actually. Alright, I repopulated all of this, and my new cap is right here. I put a new inductor in it too, just for the heck of it. But unfortunately, still no horizontal sink. It's a little bit better. I can actually see the score now, but it's still not sinking. I did order, this is a video amplifier chip. It's a LM or UA, depending on who's making it. 733. It's kind of an oddball chip, and it amplifies the crystal. And I ordered one of those. It's a linear part. There's 50% chance that it's funky. So I did order some of those. That cap was absolutely bad. So, you know what I could do is I could remove and just test all of these video. These are all video output transistors. This is the this is the crystal transistor. And then these are all video transistors, video out. So I could actually remove those and just test them and make sure that they test good. I could do that. I might as well. Alright. Yeah, let me do that. Just go through and test out all these transistors. I have to get this board to sync. And I replaced all of the 161 counters over here, and as I removed those, they just disintegrated. So those things were flaky. They just fell apart. I couldn't remove them without them falling apart. So I'm kind of glad I just went ahead and replaced those, because I don't think that they were long for this world, to be honest. I mean, they literally fell apart. So yeah, it was weird. Alrighty. Anyway, yeah, that's something that I can do now. Is I'll just test these transistors, test them all out, and make sure that they're all testing good. And yeah, move on from there. All right, lo and behold, I removed all of these transistors. This one and these 8, tested them all. They're all good. There were 2 more of those little green caps in the board. One right here and one right over here. And this cap was busted right here. It's just a 0.1. It was broken. But these 2 right here, also with my tester, my leakage tester, are no good. It's just a bad batch of caps. This is a 0.01 that I'm going to replace them with. And you'll see if I put leakage on there with my finger. Let me turn the light off and watch the LED. Alright, now I'll remove my finger and you'll see it just kind of doesn't take long, but it disappears. No leakage. That means this circuit is charging the capacitor up, and once it charges, there should be no leakage across it. See that? And the more microfarads you get, the longer it takes it to charge. I'll do a 0.0. I'll do a 0.1 next, and you'll see that. But that's a 0.01. Yeah. And once again, these ones, the LED just stays lit with these. I'll grab a 0.01 and show you that. Alright, this is a 0.1 I meant, not a 0.01. This is what I'm going to use to replace this capacitor right here, 0.1. And you'll see how long this takes. Let me, once again, I will simulate leakage. Maybe, there we go. Okay, now you'll see, once I remove my finger, how long it takes for this thing to charge and stop leaking. And the LED goes out. And it has to be completely extinguished. No leakage across it. And no leakage. Yeah. So that's a good capacitor. These 2 right here are no good. They just, the LED just stays lit. I'll show you with those 2. Bear with me a second. Just go ahead and there we go. Okay. Turn off the light. And it is on. And it just stays lit. That means the capacitor leaks current across it. I don't mean physically leaking, like leaking stuff out of it. It's leaking current across the 2 plates in the capacitor. This is a disc capacitor. It's 2 plates. It looks like that one actually went out. Finally. Yeah, see now this one is going out now. But slowly. Okay. So this one actually seems to be not leaking now. Let's try this one, if I can get on it. Okay. Now I'm on that one. Turn the light off. See, it should have already went out. You saw how a good new 0.01 acted. This should have been out way long ago. See, this capacitor's no good. Both of these are no good. Even though this one stopped leaking, but it's not really, I mean, it was leaking before, so I don't trust it. And this one just stays on, so it's just a bad batch of capacitors. They're just, I mean, they are 50 years old, so who knows? Yeah. Okay. Well, I'm going to go ahead and replace these guys, and I guess I should see if there's any more of these caps on the board, on the set. So I guess I'll do that. See if there's any more of these things on the set. I might want to remove them. Anyway, alright, I'll be back. Bad cap. Alright, well, unless I'm hooked up wrong on this, which I'm not, let me just double check. And this is the danger with marking something as good just because it looks halfway decent. Okay, I'm on there. This is input number 1. This is input number 2. And this is output. Absolutely not right. This is an 86. LS86 is an exclusive OR gate, which means the only if this should be a 1 because it's an OR. It's an OR unless they're both high. If you have two high inputs, then it'll be low. Otherwise, the output will be high if you have either or of these high, but not both. If they're both high, that sends the output low. This should be high this whole time. Because you have a high input and a low input, you should have a high output. This thing doesn't work. That is absolutely incorrect for an 86. So, yeah. What I had done with these was I put a green dot if it looked like they had a good digital signal. That did not mean that the signals were actually processed correctly, and this is obviously not correct. So I'm going to go through all of these simple gate chips with this guy to just verify. I've already found that that's a bad chip right there. And that's the first one I got on. The first one I hooked up to, I was like, wait a second. I'm like, really? Simple. Okay. I'm going to continue on and just go over all of the 2 and 3 input gates I can do with this. Like the 10s, the 00, 02, all that kind of stuff I can do with this guy. So I'm going to go ahead and do that. And along with my green dot, if they verify good with the signals, I'm going to put a gold dot, which means they're golden. They're good to go. This one gets a red dot. So, all right. I'll be back. And here is an example of an LS86 that's working properly. It's the same chip, but a different gate in the chip. You have a clock signal, a clock-like signal up here. And here you have a high, which a high is going to invert this signal. Because if they're both 1, you get a 0. And if either or is a 1, but not both, then it'll be 1, right? So you have 0, 0. No, you have 1, 0, so it's a 1. Then you have two ones, so it's a 0. And 1 0, you know, a 0 and a 1, so it's a 1. This is inverting, and now when this goes low in an 86, this is actually just going to drive the signal now. If this one's a low, it acts as an OR gate. So when this is high, it'll be high down here. So that is an 86 that's working properly. And what's promising is if we look at and find our gate, which is right, it's A4. If I can find it again. I had it, but right here. This guy. This was our bad output on pin 3. This was our bad output. And if we follow that line where it says 11, it's actually pin 3. If we follow that down, just keep on that line. Now it turns. That line is, it's turning on this transistor in the video output. Yeah, so that's going to have a major implication of this doing this. So yeah, I mean that's promising. So I'm glad to have found that. Even though it looked like a digital signal, it just wasn't right. So all right, I'm going to continue on. I'm just going to continue and do like I said. I want to verify all of these simple gate chips. Okay, I replaced that 86. And yay. We are synced. It's not great, but I remember I watched John's Arcade's video on this, and his jiggled up here a little bit too, so I think that's just normal. This thing just got a weird sync, and plus it's probably not, it'd probably sync better to the TV, I would think. I don't know. But I think that's as good as it's going to get. Yes, I know John's Arcade, his computer space did a little, it was hard to get it locked in up here as well. But that looks good. I'm going to put the other boards in there and see how it looks. All right. The customer did send this along, which was great. Plugs into here. And I have this thing, I have all the boards in, and it's kind of working. That's the rocket ship, which looks totally jacked up, which is to be expected. I mean, I don't have all the diodes in over there, and I'm missing one of the chips. Seems to be counting up good. That's good. Starts off with 5 points for some reason. That's not good. Saucer looks halfway. I think the saucer looks good, to be honest. Yeah, it's counted to 0. Let's do it again. Let's start up again. Just coin. I might have a coin in it. I don't know. Nope. Okay, coined up. Start game. There. Yeah, this is going crazy. This did. It went from 0 to 9. So there's a bad counter. That's no big deal. This seems to be counting good. So the saucer looks good. That's counting. That's nice. Rotate. My ship rotates if I do it, you see. But it just looks goofed up because I don't have all of the diodes and stuff in there. This rotate button is jacked up. See, it's rotating all the time now. This button's got issues. Yeah. It's like stuck. See, now it's not rotating. I'll hit this rotate button, it's rotating. See, the rocket looks pretty good. If I thrust isn't seeming to do anything. Yeah. So it's got some more, kinks to iron out, which is no big deal. I mean, we got some rocket stuff that I need to actually complete. No big deal. And then the logic for the counting is not a big deal. And we'll have to hook up the sound. And we'll do that. Hook the sound up to it and yeah, go through all that. This board right here does have a lot of those little green capacitors that are bad. So I might just remove all of these caps, because this is all going to be critical to the sound section, all this analog. So I want to make sure all those caps are not leaking, aren't leaking current across them, because that will mess up sounds, if not kill sounds altogether. So cool. The saucers look good. That's nice. Okay. All right. Well, I think I can look at the schematic. I'm going to go over the schematic tonight and look at this counting circuit. What makes this count, the player count? I'm curious about that, and yeah, and we'll get to it. All right. I'll be back. And I did just adjust the screen. If you put the crosshatch on, it's about as good as it gets. It's really fidgety. This isn't, this is early. It's not, doesn't have the greatest sync potential, but this is as good as it gets. I mean, it looks good. I think it looks good. Pretty stoked. Computer space. This was a pretty jacked up board set, man. You know what? But this one is worth putting all of the time and effort into. Preserving this is very important. Yeah. Gosh, look at that. How cool is that? Computer space. We're most of the way there. The sauces are looking good. We need the counting. We need the player counting, right? This needs to be worked on a little bit and fixed up. And, just finish off some of the logic and this thing will be good to go. Cool.